Swayam Prabha. Digital India. Educated India.
Namaste and welcome to the video course on watershed management. In module 3, lecture number 10, we will discuss today rainwater harvesting system. So, some of the important topics covered in today's lecture include introduction to rainwater harvesting, hydrological aspects of rainwater harvesting, hydrogeological aspects, groundwater recharge and integrated system for rainwater harvesting, then a case study. So, some of the important keywords in today's lecture include rainwater harvesting system, hydrogeology, groundwater recharge. So, we were discussing about the watershed management and we have seen that the water availability and then related water resource issues are major issues as far as the total development plan of a watershed. So, that way water is one of the most important issue as far as the watershed development plans are concerned. So, water we are getting mainly through rainfall and this water say as we have already seen say convert to runoff and then so many losses takes place and in the hydrological cycle this water will be transformed from one form to another form. So, the main purpose of this rainwater harvesting is to obtain the water wherever it falls, say for example, in a watershed on a watershed basis, say if the rainfall takes place in that particular area. So, we want to capture that rainwater in that particular area and then utilize. So, that is the basic concept of rainwater harvesting. So, that way we can define the rainwater harvesting as a process of collecting, conveying and storing water from rainfall in an area say for beneficial use. So, the use can be either domestic purpose, agricultural purpose or any other purpose. So, generally the storage can be in tanks or in reservoirs or like underground storage like groundwater. So, we have already seen that say for example, if you consider a country like India, we have say the rainfall variation is too much, say like rainfall is there mainly in the monsoon season and that is mainly 3-4 months starting from June to September or October, and the variation is also spatial. So, you can see that if you consider this rainfall map of India, in some locations the rainfall is more than 200 centimeter per annum and even some location it is more than 4000 millimeter, 5000 millimeter, and in some locations the rainfall is say to the tune of 20 centimeter or 200 mm or less than that. So, that way spatially the rainfall availability is varying from one location to another location. So, that way the available water resource, the available rainwater we have to utilize in an effective way. So, that way rainwater harvesting is very much essential. So, the necessity of rainwater harvesting is due to mainly temporal and spatial variation of rainfall and the water availability. So, if you consider say for example, the rainfall pattern in Aizawl and then rainfall pattern in Delhi. So, you can see that the rainfall in Aizawl it is almost say it is about more than 8 months and the variation is say good distribution is there, but in Delhi you can see that mainly the rainfall is only for 3 months and average rainfall is about 700 mm per year. So, that way the rainwater harvesting is very important. So, wherever the rainfall takes place we want to harvest it and then we want to use it especially in that particular location or particular watershed which we consider. So, when we consider the rainwater harvesting, so this say now this rainwater harvesting has been used by our forefathers for centuries, but due to the say recent negligence of this rainwater harvesting say for last few decades. So, in many locations we have got lot of water related problems. So, that way rainwater harvesting is not a new technology, but a forgotten technology which we have to now revive on a large scale. So, that way rainwater harvesting we can define it as a technology used for collecting and storing rainwater from rooftop, land surface or catchments or say watershed basis using various techniques such as tanks or check dams or recharge to the aquifer system as we discussed. So, we can see that this say since we are collecting the water at that particular location and trying to use there itself. So, that way rainwater harvesting is the most promising alternatives for supplying fresh water in the face of increasing water scarcity and escalating demand. So, we can see that due to the growing population due to industrialization and then we are expanding our agriculture. So, that way we need lot of water and say we have already discussed earlier that more than say if we consider India more than 60% of the country's say rainfed agriculture. So, if we can provide water for irrigation purpose, then we can increase the yield from the agriculture. So, that way rainwater harvesting is one of the most important aspects say as far as the any watershed management plans are concerned. And now, let us see what are the basic components of rainwater harvesting. So, of course, one of the important components, the most important component is rainfall or precipitation. It can be either say as a rainfall or a snowfall. And then second important component is collection of water from the surface catchment. So, we have already seen the rainfall is converted to runoff and this runoff is that what we have to capture and then that is what is the yield from that catchment. So, the collection of the second important component in rainwater harvesting system is the collection from the surface catchment. It can be a rooftop or a land surface or just like a watershed. And then the next component is water storage. So, we have to store this collected water either in tanks or reservoirs or we can also recharge to the aquifer system. So, water storage. So, we are say whenever rainfall is there we have got plenty of water. So, that some portion of that water we are trying to store for future use. So, that way the storage can be say just for like a domestic purpose we can store in tanks and for agricultural purposes we can store in small reservoirs like this or like this. And then say most of the other times we can say even recharge to the aquifer system. So, that way we can utilize this available water say during the lean period. And then the next component is distribution of water. So, the distribution once it is collected we have to distribute the water. So, it can be through say small channel system, canal system or through piping systems or it can be also pumping system from the groundwater. So, these are the important components of a rainwater harvesting. So, now say let us discuss why we have to do this harvesting, so called rainwater harvesting. So, we have already discussed important aspects of rainwater harvesting. So, now why it is so important. So, here in this slide I have put say rainwater harvesting yield copious amounts of water. Say for an average rainfall of about 1000 millimeter, approximately 4 million liters of rainwater can be collected in a year in an acre of land. So, an acre is almost approximately equal to 4047 square meter. So, post evaporation, if 1000 mm is the average rainfall, then we can say approximately say get 4 million liters of rainwater. So, that is the advantage. So, say so much water we can collect if depending upon the system which we utilize. And then say this rainwater harvesting is neither energy intensive nor labor intensive. So, a cost effective alternative to other water accruing methods such as desalination of seawater and water transfer from one basin to another basin. So, there is no need of any energy or say electric power to do this rainwater harvesting, and then once a system is made it is not labor intensive, only some annual maintenance is sufficient. So, that way rainwater harvesting is very attractive. And then Another important aspect is, say, as I mentioned, say we can recharge this water to the aquifer system. So, with the water table falling rapidly and with the concrete buildings, paved car parks, business complexes and landfill dumps taking the place of water bodies, rainwater harvesting is the most reliable solution for augmenting the groundwater level to attain self-sufficiency in public distribution of water. So, groundwater has an important role as far as the water plants of any country. So, this water, say if you overdraft, then the groundwater table will drastically go down. So, that way we have to recharge, say whenever rainfall is there, whenever sufficient surplus surface water is there, say especially since now the non-pervious area, like due to built up areas are increasing, especially in city and other areas. So, that way we can collect this water and then recharge to the aquifer system, then we can utilize back this water as groundwater, so that we can attain self sufficiency in the public distribution of water. So, that is the advantage. So, these are the reasons why we have to go for rainwater harvesting. So, now let us see what are the purposes of rainwater harvesting. So, the rainwater harvesting can serve the following purposes. So, mainly two major purposes. So, one is mainly for agricultural use. We can say directly harvest the water just like in a check dam like this, and then we can use it for agricultural purposes. And then say just like in cities, we can use the rooftop rainwater harvesting system, where water can be directly collected in tanks, and then we can use it for human consumption. Then other purposes include, we can increase groundwater recharge as we already discussed, and then we can reduce stormwater discharges, urban floods and overloading of sewage treatment plants. So, you can see that if we can recharge more water to the aquifer system, then the surface runoff will be reduced. So, that way we can reduce the urban flooding problems, and then also in the stormwater system the runoff will be reduced. So, stormwater capacity can be reduced, and if we can go for more recharge to the aquifer system. So, that way it is advantageous. And then another advantage is that we can reduce seawater ingress in coastal areas. So, in coastal areas we can see that due to the overdraft of the aquifer systems by huge pumping, say most of the time the seawater intrude to the coastal aquifer system. So, if we can go for recharging say rainwater, using rainwater harvesting in these areas, so then say more water will be coming to the aquifer system, so that the seawater what is trying to ingress to the aquifer system, that will be going back to the, so that say we will be having more fresh water from the coastal aquifer system. So, that way we can use this rainwater harvesting as a methodology for to reduce this seawater ingress in coastal areas. So, now say we have seen the necessity of rainwater harvesting, and then purposes also we have seen. So, now various methodologies we can adopt as far as rainwater harvesting is concerned. So, some of the important methodologies are listed in these slides. So, say the water harvesting we can undertake through various ways. So, some of the important say methodologies are listed here, like capturing runoff from rooftop. So, we can directly capture the rooftop rainwater, and then either that can be stored in tanks on an appropriate way, and then we can use it for future use, or we can use that water for recharging purpose. So, that is generally called roof water harvesting. So, in this we capture the runoff from the rooftops. Then second one is we can capture runoff from local catchments. So, that we call it as land harvest. So, you can see that say even in city areas lot of land will be there as say pavements and gardens, etc. So, this water we can harvest in an appropriate way by collecting through the small channels, and then we can filter it through through some sumps, and then we can use it for mainly for recharging purpose. So that is the second methodology. So we can capture the runoff, and then we can use for especially recharging. So that is so called land harvesting. And then third one is we can capture seasonal flood waters from local streams. So especially whenever small rivers are going, so whatever is coming through the river system, the runoff, we can have small check dams like this, and then we can have storage, so that can be directly used for agriculture purpose, and also this this can be utilized for recharging purpose. So the nearby aquifer system will be also recharged in this way of rainwater harvesting. And then also we can go for we can conserve water through watershed management. So watershed management, various practices are there, like land based or the stream wise, various practices we can follow in watershed management, rainwater harvesting. So that is the fourth methodology. And say especially for urban and industrial environment, so generally we go for say roof and land based rainwater harvesting system. So you can see that here the roof water what is coming, we can directly collect it and directly store or use for recharging. So this can be done in public, private, office and industrial buildings. And then land based is say just like this lot of land is there in the urban areas, so like pavements, lawns, gardens and other open spaces. So this water we can collect it and either we can put it in a small pond and then utilize, or we can allow this water to recharge to the aquifer system. So that way the land available even in industrial or urban areas we can directly utilize. So these are some of the important methodologies of rainwater harvesting. So now within this perspective, let us look what are the important advantages of rainwater harvesting. So there are number of advantages of rainwater harvesting. Say as far as disadvantages or limitations, there are no as such there are no limitations, since it is always beneficial. So some of the important advantages are listed here in the slides. Rainwater harvesting provides self-sufficiency to water supply, as we already discussed, then reduces the cost of pumping of groundwater. So when we are recharging, the water level rises, so that way we can reduce the cost of pumping. Then provides high quality water, soft and low in minerals. So especially for industries where hard water is an issue, so then we can say rainwater is soft water and low in minerals, so that directly we can utilize, since the quality of the rainwater is very high. Then it improves the quality of groundwater through dilution when recharged to groundwater. Say especially in some areas wherever the groundwater pollution is there, if we can recharge a good amount of rainwater, then dilution will take place, and then that the groundwater itself will be getting the quality will be getting better. Then the rainwater harvesting helps to reduce soil erosion in urban areas. So various structures which we constructed for rainwater harvesting, that will reduce the soil erosion. Then rooftop rainwater harvesting is less expensive. So if you do a cost analysis, we can see that this is one of the less expensive way of say water conservation and utilization. And then rainwater harvesting systems are simple, which can be adopted by individuals. There is no complicated technology, the technology is very simple, we can easily adopt it. Then rooftop rainwater harvesting systems are easy to construct, operate and maintain. So simple design and operational maintenance are very simple as far as rainwater harvesting is concerned. And then some other important advantages, say in hilly terrains rainwater harvesting is preferred. So there we can, especially if the slope is very high, then we can see that most of the water will be drained out. So there if we can store, or we can use for rainwater for recharging in hilly terrains. Then in saline or coastal areas, rainwater provides good quality of water, and when recharged to groundwater, it reduces salinity and also helps in maintaining balance between the fresh saline water balance water interface. So this we have already seen, we can reduce the saline ingress to the coastal aquifer systems. And then in islands, due to limited extent of freshwater aquifers, rainwater harvesting is the most preferred source of water for domestic use. So, especially in islands, say wherever say surrounding say all the four sides are surrounded by sea, then you can see that even the aquifers on the coastal sides may be affected by saline water. So, there if we can directly harvest and we can directly utilize the rainwater. Then in desert region where rainfall is much less, rainwater harvesting is the only source of say water. So, many areas this rainwater harvesting has been implemented and has been found to be a huge success as far as arid and semi-arid regions are concerned. So, we can this way we can see that only advantages are there as far as rainwater harvesting is concerned. Even though at the beginning there may be, say we have to invest some more money, but within 1 or 2 years whatever invested money we will get back, as this is one of the say less expensive way of water conservation and water use. So, now as far as rainwater harvesting is concerned, different techniques, different technologies are available. So, some of the important techniques are listed in this slides. So, this depends upon the area, depends upon say what kind of topography, etc. So, accordingly we can say the technology can be classified into mainly for 3 types of areas. So, first type of say type is for rainwater harvesting structures. So, depending upon say we have to see depending upon the topography. So, topography means say what is the slope of the land, what kind of soil, and then so also it depends upon the rainfall, and then what kind of structures we can implement like economic status. And then built up areas are concerned, say we can go for tanks like in traditional temple tanks, then rooftop harvesting, then wells and radiator wells, parking lot storage, recreational park ponds. So, various schemes we can develop for built up areas. Then open areas like in a watershed, we can go for percolation ponds where water will be say stored for some days, so that will be a source for recharge as well as utilization for domestic or agricultural purposes. Then we can construct infiltration galleries, then community wells, farm ponds, ducts, anicuttes across the stream, etc. So, there are various techniques are available as far as rainwater harvesting is concerned. So, depending upon the area, depending upon the requirements, depending upon the money which we can invest, we can choose particular technique for that particular location. And so, it depends upon what is the use of the rainwater what is harvested, say like whether domestic consumption or whether it is for agriculture purpose or for gardening. So, accordingly we need a good quality water, or say the quality can be say slightly less, say for example if it is for agricultural or gardening purpose. So, that way we can choose appropriate technology for rainwater harvesting, and then that we can implement. So, now let us go back to say how much water we can harvest, say as a say for example a particular area is concerned or a particular watershed is concerned. So, rainwater harvesting potential let us look into. So, the water yield from a catchment, so the rainwater harvesting a catchment depends on the amount of rainfall, watershed slope, types of soil and vegetation, and the evapotranspiration ratio. So, accordingly the rainwater potential varies. So, depending upon the area, like how much is the rainfall and then how much is the intensity, what is the duration of rainfall, then what is the slope of the land, then what kind of soil. So, infiltration rate depends upon the soil type, and then vegetation of the area. So, since evapotranspiration depends upon that. So, then accordingly, so depending upon say the vegetative cover, say like vegetation management we can do. So, in such a way that we can go for improved management of vegetation, so mainly applicable to large areas, and water yield from a grass cover is more than that from a forest cover. So, depending upon the area we can do a vegetative management. And then we can also go for land alteration. So, depending upon what kind of whether it is built up land or it is open space. So, accordingly the rainwater harvesting potential varies. So, alteration of land surface of a catchment, say from pervious to impervious, then there will be lot of changes will be there. The runoff will increase when it goes to pervious to impervious. And then laying of paved surface on sloping catchment along with drains at their sides. So, accordingly, say for example, nowadays porous pavements we can make. So, then some portion of the water will be recharged. So, like that we can do land alteration. Then collection of catchment runoff in storage tanks. So, depending upon the area we can do. Then say the method is preferable where the land surface is undulating. So, depending upon the catchment, depending upon the rainfall condition, depending upon the vegetation, the rainwater harvesting potential varies from one location to another location. So, accordingly, we have to do a study and then identify what will be the potential of rainwater harvesting for the particular area is concerned. So, now let us look into the hydrological aspects of rainwater harvesting. So, mainly the important component is the precipitation or snowfall or say the runoff taking what is coming from the rainfall or snow melt. So, accordingly, the hydrological aspects are very important as far as rainwater harvesting is concerned. So, as we already discussed earlier, the hydrology is the study of water. So, although there is plenty of water on earth, it is not always in the right place at the right time and of the right quality. So, this we have already discussed. So, through hydrological studies we are trying to understand the complex water systems of the earth, and we are trying to solve various water related problems. So, just like say how much water can be harvested, how it can be harvested and where it can be harvested. So, like that. So, as far as hydrology is concerned, say as we discussed, rainfall is the main source of water. So, which we are trying to utilize in different ways. So, the hydrological cycle, as we discussed earlier also, that is one of the important aspects what is happening with respect to rainfall to runoff, and then this passing of the runoff to the sea, and then evapotranspiration and condensation, like that. So, the in hydrological cycle say water is say change in one phase to another phase in the hydrosphere. So, the balance of water on earth remains fairly constant over the time. So, even though the population is increasing, the water demand is increasing, the agriculture is increasing, but the water availability say it is almost say remains constant over time. So, that way we have to use judiciously in such a way that with respect to the available water we have to manage our demand. So, that way the hydrological studies is very important in the for rainwater harvesting for a particular area. So, as I mentioned in hydrological studies we have to see how much is the runoff potential for a particular area. So, rainfall to runoff. So, we have already seen various processes will be there with respect to rainfall to runoff. So, various processes such as evaporation, transpiration, then infiltration, interception, and then percolation, like that various processes will be there. So, this we have to consider when we go for rainwater harvesting. So, the various processes and pathways determine how much and how fast the precipitation becomes the stream flow or converted to runoff. So, some of the important factors as we discussed are the precipitation form, the intensity of precipitation, duration of the precipitation, and the distribution of the precipitation within an area or within a watershed. And then also it depends upon how much is the water storage, especially in the soil. So, like soil moisture and then how much say area is saturated. So, once the soil is saturated, then only the runoff starts. And then the flow pathway. So, like say for example, the shallow soil layer versus deeper soil layer, or overland surfaces or subsurfaces. So, like that the flow path is very important say when the rainfall is converted to runoff. And then the spatial distribution and geomorphic features. So, what is the geology of the area, what is the geomorphic pattern of the area. So, depending upon this the the rainfall to runoff conversion takes place, and then we will be say we can identify how much is the possible storage. So, then also we can see that the meteorological factors very important. So, the precipitation, since we are most of the time we are depending upon the precipitation as far as the source of water as far as rainwater harvesting is concerned. So, the type of precipitation like rain or snow, then rainfall intensity, say how intense, whether it is the intensity is very high or low intensity, so that we can identify how much is the amount, and then duration of the rainfall, and then distribution of rainfall over the drainage basin, then direction of storm movement, precipitation that occurred earlier and resulting soil moisture. So, this depends upon the runoff conversion, rainfall to runoff depends upon the infiltration. So, if the soil moisture is already there with respect to previous rainfall, then you can see that the runoff generation will be faster. So, that way these are some of the important issues which we have to discuss as far as the rainfall to runoff conversion is concerned. So, now within this perspective, say let us discuss as far as rainwater harvesting is concerned, how much water can be harvested. So, that let us discuss say for a particular area. So, when the rainfall is converted to runoff, so the total amount of water that is received in the form of rainfall over an area is called the rainwater endowment of that area. So, rainwater endowment means it is based upon the total amount of rainfall say taking place for that particular area, and out of this the rainfall, the amount that can be effectively harvested is called the water harvesting potential of that particular area. So, when we design a rainwater harvesting system, say first we have to see what is the rainwater endowment, and then we have to identify what is the rainwater harvesting potential as far as the area is concerned. So, the rainwater harvesting potential we can put as that is equal to rainfall into the collection efficiency. So, we can see that number of losses will be there, like evaporation will be there, then the infiltration will be there, and then the collection related problem will be there. So, accordingly the water harvesting potential depends upon the rainfall and the collection efficiency. So, that is equal to rainfall multiplied by the collection efficiency. So, the collection efficiency accounts for the fact that all rainwater falling over an area cannot be effectively harvested because of evaporation, spillage, etc. So, that way we have to account a factor called runoff coefficient. Generally, in most of the design of rainwater harvesting, we take a coefficient called runoff coefficient, and then use this coefficient to identify how much will be the water harvesting potential for that particular area. So, this runoff coefficient, it is a factor that accounts that all the rainfall falling on a catchment cannot be collected or harvested. So, some rainfall will be lost from the catchment by evaporation, infiltration, retention, like that say on the surface itself. So, that way we have to identify this runoff coefficient for the given location or given area. So, some of the runoff coefficient for various surfaces, few of the surfaces I have listed here. This is based upon this reference. So, the type of catchment, the runoff coefficient, say for example, roof catchments. So, if it is tiles, it may vary from 0.8 to 0.9, then corrugated metal sheet, it can vary from 0.7 to 0.9. And then ground surface coverings, like if it is concrete, it can vary from 0.6 to 0.8. If it is brick pavement, it can vary from 0.5 to 0.6. And then if it is untreated ground catchment, so soil on slopes less than 10%, it will vary from 0 to 30% or 0 to 0.3. Then rocky natural catchment, it can vary from 0.2 to 0.5. So, like that say depending upon the area where you are going for rainwater harvesting, we have to identify what will be the runoff coefficient. So, the runoff coefficient depends upon the nature of the surface. So, whether it is concrete, whether it is soil, or whether it is pavement. So, accordingly the runoff coefficient will vary. So, this runoff coefficient standard values are available based upon number of field experiments or laboratory experiments. So, based upon your area where you are going for rainwater harvesting, we can choose particular runoff coefficient. So, now the question comes, how much water can be harvested. So, this figure is taken from CSC India website. So, this is the area of the catchment, say for example, if it is roof. So, this much is the area of the catchment. So, then multiplied by amount of rainfall. So, if we can identify how much is the amount of rainfall, whether it is 100 mm or 1000 mm. So, that will give the volume of water received. So, that is the total volume. Then of course, we have to multiply by a coefficient called the runoff coefficient depending upon the collection efficiency and the area. So, now if you plot, say for example, in this figure, so this is the months and this is the variation. So, here you can see that so depending upon the location, the rainfall varies, monthly variation takes place. So, if this is the monthly average monthly variation for that particular area, and if this is our the demand of, say, for the water is concerned, then you can see that, say, this is the lean period, and here we have so much of water due to the rainfall. So, depending upon that depending upon the rainfall pattern and depending upon the demand of that particular location, we can design a particular rainwater harvesting system for the desired requirement for the particular area is concerned. So, accordingly we can calculate how much is the rainwater harvesting. So, the calculation is based upon, we can say for example, if you consider a building with a flat terrace area of 100 square meter, the average annual rainfall be approximately 900 mm. So, it means that if the terrace floor is assumed to be impermeable and all the rain that falls on it is retained, then in 1 year there will be rainwater on the terrace floor to a height of 900 millimeter. So, area of the plot is, say, the 100 square meter, height of rainfall is 0.9 meter. So, volume of rainfall, area of plot multiplied by the height of rainfall. So, it will be about say 90 cubic meter. So, if, say, for the due to various reasons like the collection efficiency and then various losses, then if 70% of the total rainfall is effectively harvested, then we can see that how much we can harvest for this particular 100 square meter area will be 63,000 liters by considering the collection efficiency of 0.7. So, like that we can calculate how much is the rainfall, say rainwater harvesting can be done depending upon the type of the location, say whether it is rooftop or it is, say, open space, and then how much is the rainfall and then how much is the collection efficiency. So, this collection efficiency is concerned, say how efficiently the rainwater can be collected, as we discussed already, it depends upon several consideration. So, say maximum of say we can consider 80% collection efficiency depending upon various aspects for the specific design is concerned. And then the other issue is rainfall reliability. So, the main step is to determine how much water would be generated from the roof area. So, average monsoon rainfall is used for this purpose, and then as we have already seen in the previous slide. So, the variation according monthly variation we can consider, and then we can plan, okay. So, for this many months directly we can utilize from the rainfall, and this much can be collected for the coming months. So, the simple formula is total quantity of water to be collected is equal to rooftop area multiplied by the average rainfall into collection efficiency as we discussed earlier. So, now let us come back to the scenario in India. So, as we all discussed in India, because of distinctive climate due to the monsoon rainfall pattern, the storage of rainwater at appropriate sites become very important. So, we have some areas of, say for example, in location like Kerala 8 months rainfall is there, but in many other locations say 2 months or 2 to 4 months rainfall. So, depending upon the area and depending upon the rainfall pattern, we have to go for the rainwater harvesting system. So, 80% of annual rainfall say for India is concerned, the average annual rainfall is we can consider as 1170 millimeter, and out of this 80% will be received in 3 months of time starting from July, August, September. And during rainfall season, all the rainfall is taking place in about 200 hours, and half of it will be happening in 30 to 40 hours. So, this is the main issue. Even go for rainwater harvesting, we need to specifically design particular rainwater harvesting depending upon the location. So, consequently, runoff is very high in most of the locations, and if it is captured and stored, it can be used effectively later on. So, while going for a rainwater harvesting design, we have to identify what is the rainfall pattern, whether it is distributed say for 4 months or 8 months, or what is the intensity and how many days of rainfall and how many hours of intense rainfall. Accordingly, we can design. So, now say for example, if Mumbai is concerned, say rainfall in Mumbai, the average total annual rainfall based upon the data of 25 years is about 2335 millimeter. So, for the Mumbai area, and the rainfall is varying like this, say the main rainfall season is June, July, August to September, and number of rainfall days say it varies depend upon the month also. So, so when we go for a design, rainwater harvesting design, so we have to get such plots, say average annual rainfall pattern, monthly base pattern, and then how much is the average annual rainfall and the number of rainy days. So, these kinds of data will be very helpful to design appropriate rainwater harvesting system for that particular location. So, the rainwater harvesting system can be either rooftop based system or the land based system or the watershed based system. So, we have to see the hydrological aspects as we discussed, say the rainfall variation, monthly variation, and the rainfall intensity variation, then number of days or number of hours of rainfall. So, all this data we have to collect appropriately, and then we have to utilize this data to identify how much is the rainfall potential, and then we have to identify what will be the runoff coefficient, and so that we can go for a better rainwater harvesting design system. And now, as we discussed earlier, so one of the important aspect of rainwater harvesting is groundwater recharge. Since say we cannot store so much of water on these surface reservoirs or tanks for immediate use. So, the best solution will be rainwater harvesting will be to store the water underground, or so called in aquifer system. So, for that say we have to study the details of the geological pattern of that particular area when we go for recharging, especially artificial recharge design. Of course, natural recharge takes place, but to increase that recharge we can go for artificial recharge. So, the hydrogeology of the area is very important. So, this depends upon the nature and extent of the aquifer, soil cover, topography, depth to water levels, and then of course, chemical quality of the groundwater. So, this figure shows the various rock formations of India. So, say for example, the geology of India is as diverse as its geography and people. And so, the people culture and the nature varies from one location to another location. So, very similar way the geology of India is also varying. So, it contains rocks covering almost the entire spectrum of the geological time scale, like Archean, Deccan Trap, Gondwana supergroup, Vindian supergroup, etc. So, this graph is taken from Central Groundwater Board website. And then so as I mentioned, the main source of groundwater is, say, this infiltration taking place during the rainfall or the recharge to the aquifer system. So, water resource as a result of hydrogeology. So, some of the important parameters which we have to consider in the process of these kinds of the infiltration or percolation to the aquifer system depends upon the soil thickness, distribution of rock exposures, pore networks in the rocks, then water recharge areas, discharge locations, general flow direction of groundwater, and then fluid flow characteristics of main aquifer types including the yield, and then ground features like lineaments. So, all these we have to study in details. So, before going for a rainwater harvesting design, especially in terms of the groundwater recharge or aquifer recharge, we have to see the geological pattern of that location, especially watershed basis. We have to see the geological pattern, the soil pattern, the soil thickness. So, all these we have to see while designing appropriate rainwater harvesting structures, especially for groundwater recharge. Say for example, this is the hydrogeological map of India. So, we can see that say depending upon the location the hydrogeology change. So, accordingly the rainwater harvesting for recharge also the methodology will vary, and then the recharging rate also will vary. So, now as we already discussed, groundwater is the major source of water supply in many parts of the world, and groundwater collects in aquifers over thousands of years through infiltration and groundwater flow recharge. A particular amount of groundwater is replenished regularly through rainwater infiltration. So, natural infiltration takes place, but through artificial way we can increase this recharging. So, sustainable use of groundwater means withdrawal of groundwater at a rate at which it is replenished through recharge. So, if we are using particular amount of say groundwater, then that amount should be replenished through the year due to the rainfall taking place, so that sustainability will be there. Otherwise, what happens if you keep on pumping, and if sufficient recharge is not taking place to the aquifer system, the groundwater level will drastically go down. So, that you create say other problems. So, we have to see a sustainable recharging pattern for the particular area. So, faster withdrawal rates would lead to fall in water table and finally depletion of the groundwater. So, the groundwater recharge areas need to be identified. So, particular area depending upon the soil nature, vegetative cover, etc. We have to increase the recharge possibility. So, we have to identify the area, and then we have to design appropriate structures as far as the rainwater harvesting is concerned or recharge is concerned. So, this figure shows the major aquifer system of India. So, depending upon that we can plan the recharge structures, especially when we go for artificial recharge. So, the groundwater recharge is concerned, groundwater availability depends upon the recharge, as we already discussed. So, the groundwater is controlled by the hydrogeological situations characterized by the alluvial formation and the type of rock. So, the groundwater quantity depends upon the potential areas and availability of unsaturated zone for recharge. So, when we before we go for artificial recharge, as I mentioned, we have to study the details of the hydrogeological pattern, and then how much aquifer the developed aquifer system, then availability of unpolluted surface water, then groundwater dependent community. So, whether how much usage is taking place for the particular area. So, as I mentioned, the recharge can be natural recharge or artificial recharge. So, natural recharge means naturally occurring water added to an aquifer depending upon the rainfall pattern. Then natural recharge comes from precipitation or storm runoff. Then artificial recharge means we are providing particular structures to increase the recharge rate. So, this we store surplus surface water underground, and that is allowed to recharge, putting surface water in basins, furrows, ditches or other facilities. So, artificial recharge nowadays say many of the government agencies are giving a lot of importance for artificial recharge techniques. So, depending upon the area, depending upon the needs, various techniques are available as far as artificial recharge is concerned, like direct surface techniques like simple flooding, basins or percolation tanks, then stream augmentation, ditch and furrow system, and over irrigation of the area. So, these are some of the direct surface techniques. Then we can go for direct subsurface techniques like injection wells or recharge wells. recharge pits and shafts, duct wells recharge, borehole flooding, natural openings, cavity filling, etc. And then also we can have combined surface and subsurface techniques like basin or percolation tanks with the pit shaft or wells. Then we can go for indirect techniques like induced recharge from surface water source, aquifer modification, etc. So, these are some of the important artificial recharge techniques we can adopt depending upon the area. So, as far as rainwater harvesting structures especially for recharge is concerned, depending upon the area, depending upon the location, we can have various structures like a storage of rainwater on surface for future use. So, that is the rainwater harvesting through recharge. So, the recharge to groundwater say through pits, we can have pits like this or trenches like this. So, trenches, duct wells, then through hand pumps wells, recharge shafts. So, various techniques we can adopt, then lateral shaft with the bore wells, spreading techniques. So, this website gives various techniques of rainwater harvesting structures for especially for artificial recharge. So, while doing this artificial recharge, most of the time we have to also identify how much groundwater recharge is taking place. So, simple techniques are available to do this to quantify how much recharge is taking place. So, most commonly used techniques are soil water balance methods. So, in this the recharge is equal to the precipitation minus evapotranspiration plus the change in soil water storage minus the runoff. So, that is soil water balance method. Then we can use simple groundwater level fluctuation method. So, there the whatever we can harvest is equal to Sy into delta S plus Tp minus Rt, where Sy is the specific yield, and then delta is this rise of the water table, then Tp is the abstraction during the rainy season, and Rt is the return flow due to any irrigation which occurs during the rainy season. Then we can go for groundwater balancing method, that is a simple equation like inflow minus outflow is equal to change in storage. So, this equation gives groundwater balancing method. So, depending upon the requirement, we can go for particular simple technique and then calculate this much is the recharge taking place for that particular area. So, now some of the important design consideration of rainwater harvesting are say what kind of requirement, whether we are going for direct use just like storage, or we are going for recharge to improve the groundwater availability. And then we have to identify what will be the hydrogeology of the area, and then like nature and extent of aquifer, topography, etc. Then the area contributing for runoff, how much is the area of what is contributing for runoff. Then hydrometeorological characteristics like rainfall duration, rainfall intensity, etc. Then recharge structure should be designed based upon the availability of space, availability of runoff, depth to water table, lithology of the area. So, we can calculate how much is the runoff, and then we can estimate say we can design the rainwater harvesting technique appropriately. So, now one particular watershed or particular area is concerned, we can go for an integrated rainwater harvesting methodology. This can be based on the geology, topography, demands, water availability, infiltration rate, economic status of the users. So, integrated rainwater harvesting system we can design. So, this is a combination of rainwater harvesting structures like recharge trench, sump, percolation pond. So, this can be including the rooftop rainwater harvesting, then the land based rainwater harvesting, and then also watershed based approach. So, that way here I have put a flow chart for integrated rainwater harvesting in an area. So, this is the rainwater harvesting which we want to identify. So, we can identify how much is the built up area and non built up areas. So, built up area we can identify how much water is we want to store for direct use and how much we want to recharge. So, from the direct use after storage how much will be excess taking place. So, that we can put for recharging, and then finally, that will be contributing to the groundwater recharge. So, non built up area we can store some water in either the small reservoirs or percolation pond, and remaining water that can go as groundwater recharge. So, we can design an integrated rainwater harvesting for that particular watershed or particular area depending upon the need, depending upon the various local conditions. So, before closing for today's lecture, let us go through briefly go through a case study. So, the case study is the rainwater harvesting done in Jabua watershed. So, this Jabua watershed is in Madhya Pradesh and area is about 1800 square kilometer, and altitude varies from 380 to 540 meter, and this is a highly undulating sparsely distributed forest cover area, and 57% arable land and about 18% is notified as forest land. Average rainfall is 750 millimeter per annum, and this takes place in 20 to 30 events during June to September. So, this is classified as a drought prone region, and moisture deficit is January to May. So, you can see the pattern, and this is the rainfall pattern for the area. So, with the help of the various government agencies and non-government organization, NGOs, various measures were adopted for the area, like construction of large number of check dams, and then reservoir storages, about 144 storages storing this much water, and water conservation and groundwater recharge techniques were applied, say just like contour bunding, and then like small trenches in various landforms. So, the rainwater harvesting interventions included contour trenches, gully plugging, vegetative and field bunding, check dams, percolation tanks, etc. So, the impacts say this project started in 1995 onwards, and then when we assessed this in 2000 to 2003, the impact was say huge impacts, like about 2 to 4 meter groundwater level raised. Sufficient water for domestic and agriculture purposes were available in the area. One farming per area before rainwater harvesting, it has gone to 2 to 3 depending upon the area and crop. Then no water scarcity even in drought periods. Then agricultural yield increased from 30 to 60%, and there is the percentage forest land raised from 18 to 23%. And overall economic and social upliftment happened in this area. Even migration of the people came to nil, and the people participation in rainwater harvesting scheme, this is one of the important aspects as far as this Jabua watershed case study is concerned. So, now before closing this lecture, some of the important references used in today's lecture are listed here, and then one tutorial question, those who are going through this lecture, describe the traditional water harvesting system adopted in India. So, these details can be you can obtain through these websites. So, you can illustrate the system used for roof rainwater harvesting or groundwater recharge schemes, and then discuss the various techniques, and then discuss the merits and demerits of each system. So, these details you can see in these websites. Then few self-evaluation questions, discuss the necessity and purpose of rainwater harvesting, what are the advantages of rainwater harvesting, discuss the hydrological aspects of rainwater harvesting, illustrate the importance of hydrogeological aspects of rainwater harvesting, what are the important design consideration as far as rainwater harvesting is concerned. So, all these details for these questions we have already discussed in today's lecture, and a few assignment questions like illustrate various rainwater harvesting methodologies for various locations, how to assess rainwater harvesting potential for an area, discuss various techniques of artificial groundwater recharge techniques, what is integrated rainwater harvesting methodology. So, all these related answers we have discussed in today's lecture. So, for an unsolved problem for the listeners, so for your watershed area, prepare an integrated plan of rainwater harvesting scheme considering the water storage and recharge. So, you can identify the present supply and demand for your area, identify built up area, non built up area, then check the possibility of direct rainwater harvesting tanks, and then recharging techniques. So, all the data requirement you can collect like rainfall, soil data, then the agricultural pattern, etc. Then we can design an integrated rainwater harvesting scheme including the direct harvesting and storage and the groundwater recharge. So, this based upon today's lecture you can do for your own area. So, in this lecture today we discuss the rainwater harvesting. So, in the next lecture further we continue some more aspects of rainwater harvesting, and then particularly we will discuss the rooftop rainwater harvesting. So, with this we will close for today. Thank you very much.